Hi, we are students from University Technology of Malaysia UTM, tasked with delivering a concise educational session on a fundamental communication principle, pulse modulation and multiplexing. In brief, this short course comprises 5 main components. First, the pre-assessment. Second, a summary of the pulse modulation and multiplexing topic. Third, the Mission 3 game Ericsson education. Fourth, the post-assessment, and finally, the activity evaluation. Firstly, we would like to introduce the team members who have successfully completed this assignment. Our team consists of Tuan Haji Luqman, Al-Hakim Rosman, Muhammad Shafik Fauzi, Amir Zaini, and Nazri Rosman. We are third-year Bachelor of Electrical Engineering students taking course E3533 Communication Principles. Before we commence with this activity, we kindly ask you to begin by completing the pre-assessment. You can do this by scanning the QR code provided. The purpose of this pre-assessment is to assess your current level of understanding before delving into the course material. Your participation will help us tailor the learning experience to better meet your needs. Are you ready? Let's begin with our first activity. It's advisable to maintain your focus throughout this learning session. Let's kick off our learning activity with topic 1 on pulse modulation. This session will delve into the fundamentals of how pulse modulation works and its applications in communication systems. Pulse modulation is a versatile technique used to encode information into a series of discrete pulses, making it fundamental in telecommunications. It involves varying specific properties of the pulses, such as their amplitude, width, or position, to represent the original data. This method is crucial for the efficient transmission of data over different media, including copper wires, optical fibers, and wireless channels. Pulse modulation is a versatile technique used to encode information into a series of discrete pulses, making it fundamental in telecommunications. It involves varying specific properties of the pulses, such as their amplitude, width, or position, to represent the original data. This method is crucial for the efficient transmission of data over different media, including copper wires, optical fibers, and wireless channels. Pulse modulation includes various forms, such as pulse amplitude modulation, pulse width modulation, and pulse position modulation, as well as pulse code modulation, each tailored for specific applications and performance requirements. The technique's ability to reduce noise and interference while maximizing bandwidth efficiency underscores its importance in modern communication systems. Pulse amplitude modulation is a method where the amplitude of an analog signal is sampled at regular intervals, and these samples are then converted into corresponding pulse amplitudes. In this technique, each pulse's height directly. Pulse amplitude modulation is integral to digital communication systems because it facilitates the conversion of continuous signals into a format suitable for digital processing and transmission. Pulse width modulation is a technique that modulates the width of each pulse in a pulse train based on the amplitude of the input signal. By varying the pulse width, PWM effectively encodes the signal's amplitude information into the duration of the pulses, allowing for precise control over the power delivered to a load. This method is extensively used in motor speed control, where adjusting the pulse width can finely tune the motor's speed and torque. Pulse width modulation is also prominent in audio applications, providing high-fidelity sound reproduction by accurately representing analog signals in a digital format. Additionally, pulse width modulation is employed in digital-to-analog conversion processes, where it enables the accurate reconstruction of analog signals from digital inputs, maintaining signal integrity and minimizing distortion. Pulse position modulation is a technique where the position of each pulse within a given time frame is varied to encode the amplitude of the analog signal. In TPM, the timing of the pulses changes in direct correlation with the signal's amplitude, providing a unique way to represent the information. This method is highly efficient for data transmission, as it ensures precise timing, which is critical for maintaining the integrity of the transmitted signal over long distances. Pulse position modulation is particularly advantageous in optical communication systems, where it offers improved noise immunity and bandwidth efficiency. By ensuring that the sequence and timing of pulses are accurately maintained, PPM allows for reliable and accurate data transfer, making it a valuable technique in various high-speed communication applications. Pulse code modulation is a digital method for encoding analog data into a binary format, facilitating the transmission and storage of the original analog signals. In PCM, the analog signal is first sampled at uniform intervals, then each sample is quantized to the nearest value within a finite set of levels, and finally, these quantized values are encoded into a binary sequence. This process enables the accurate digitization of various forms of analog data, such as full-motion video, voice, music, and telemetry, preserving their quality during transmission and playback. Pulse code modulation is fundamental in digital audio and video recording, telecommunication systems, and data storage, ensuring high fidelity and resilience against noise and interference. By converting analog signals into digital form, PCM supports efficient compression, encryption, and error detection, enhancing the reliability and versatility of data communication systems. Pulse modulation finds its applications across diverse fields. In digital communication, it converts analog voice signals into digital formats for transmission over networks, ensuring clarity and minimizing distortion. In audio and video processing, pulse modulation techniques (IPWM) help in encoding and decoding signals without significant loss of quality, vital for high-definition multimedia transmission. Data transmission systems, including modems, rely on pulse modulation to convert digital data into analog signals for efficient transmission over telephone lines and radio waves, ensuring reliable connectivity and communication. Congratulations, you have completed learning topic 1, pulse modulation. Next, for the second topic is multiplexing. Multiplexing is a method used to combine multiple signals into a single transmission medium, maximizing the efficiency of the medium. In the context of pulse modulation, time division multiplexing (TDM) is often used. There are four methods of multiplexing. Frequency division multiplexing (FDM) assigns distinct frequency bands to each signal, enabling simultaneous transmission over a single medium. In pulse modulation, time division multiplexing (TDM) is a common approach where time slots are allocated to different signals, allowing them to share the same channel without interference. Space division multiplexing (SDM) involves using separate physical spaces or channels for different signals, often utilized in multiple input, multiple output (MIMO) systems in wireless communication. Wavelength division multiplexing (WDM) is particularly used in fiber optic communications, where different signals are transmitted on separate wavelengths of light within the same optical fiber, significantly increasing the data carrying capacity. Together, these multiplexing methods enhance the efficiency and capacity of communication systems, supporting the ever-growing demand for data transmission. Frequency division multiplexing (FDM) is a technique used in telecommunications to transmit multiple signals simultaneously over a shared medium. It works by dividing the available bandwidth into multiple non-overlapping frequency bands, with each band allocated to a different signal channel. This allows each signal to occupy its own distinct portion of the frequency spectrum without interfering with others. FDM is commonly used in radio communications, where different radio stations are assigned specific frequency bands for transmission. It is also employed in cable television networks to combine multiple TV channels into a single cable for distribution to homes, optimizing the use of the cable's bandwidth. Time division multiplexing (TDM) is a method used in telecommunications and digital networks to transmit multiple signals for a single communication channel by dividing it into sequential time slots. Each signal is assigned a specific time slot within the channel, ensuring that only one signal occupies the channel at any given time. TDM is crucial for optimizing bandwidth usage and facilitating efficient data transfer, especially in scenarios where simultaneous transmission of multiple signals is required. This technique is extensively used in digital telephone systems, where voice conversations are converted into digital data and allocated discrete time slots for transmission. TDM ensures that each signal receives equal access to the channel, preventing conflicts and minimizing interference between different transmissions. Space division multiplexing (SDM) is a technique used in wireless communications to transmit multiple data streams simultaneously by employing multiple antennas for both transmission and reception. Unlike frequency division multiplexing (FDM) and time division multiplexing (TDM), which utilize frequency and time respectively, SDM relies on spatial separation through antennas. This approach is particularly effective in multiple input, multiple output MIMO systems, where multiple antennas at both ends of the communication link enhance capacity and reliability in fading channels. SDM improves the overall spectral efficiency by enabling parallel transmission of independent data streams over the same frequency band. It mitigates the effects of fading and improves signal quality by exploiting spatial diversity, enhancing the resilience of wireless communications to interference and environmental factors. Wavelength division multiplexing (WDM) is a technique used primarily in optical fiber communications to enable multiple signals to travel concurrently over the same physical medium. Unlike traditional multiplexing methods that rely on time or frequency separation, WDM utilizes different wavelengths or colors of light to carry distinct data streams. Each signal is assigned a unique wavelength within the optical spectrum, allowing them to coexist and be transmitted simultaneously through the fiber optic cable. WDM significantly increases the capacity and efficiency of optical networks by enabling high-speed data transmission over multiple channels without interference. It plays a crucial role in modern telecommunications, including long-distance fiber optic networks and high-capacity data centers, where bandwidth-intensive applications demand robust and scalable communication solutions. WDM systems can be classified into two types: dense WDM (DWDM), which supports a large number of channels closely spaced together, and coarse WDM (CWDM), which provides fewer channels with wider wavelength spacing but is more cost-effective for shorter distances. Telecommunications industries use multiplexing to optimize bandwidth usage, enabling multiple phone calls or data streams to share the same physical communication channels, ensuring efficient use of resources. Broadcasting sectors utilize multiplexing to transmit multiple audio and video channels simultaneously over airwaves or through cable networks, enhancing viewer choices and channel availability. In computer networks, multiplexing techniques like TDM and FDM enable efficient data transmission and networking, supporting seamless connectivity and data exchange across various platforms. Congratulations on completing the entire module. Before that, here are the steps to complete Mission 3. To start Mission 3 in Ericsson Educate, we kindly ask you to begin by scanning the QR code provided. Next, you are invited to complete the post-assessment by scanning the provided QR code. The objective of the post-assessment is to assess your understanding after completing this brief learning session. To obtain holistic feedback on the activities conducted, we kindly ask you to complete the activity evaluation. Your input will help us identify areas for improvement and ensure we meet your expectations. We highly value any comments, suggestions, and feedback you may have.